So a lot of these angles have a special relationship, okay? So we're going to start with alternate interior angles. So when we're talking about interior and exterior, you want to look at these parallel lines right here, okay? And inside the parallel lines would be this space, and outside the parallel lines would be above and below them, all right? So alternate interior angles inside those parallel lines. Can anybody give me a pair of angles inside the parallel lines that you know are equal to each other? They have to be the same. Dan?
C and F?
Yeah, C and F, exactly. So this guy right here and this guy right here. So label them C and F, and underneath alternate interior, we can say that C is equal to F. Okay, and then we need a reason. How do we know that? Okay, we know that because we know that alternate interior angles are always equal. Okay, so we're going to use AIA. Alternate interior angles. Okay, there is another set of angles that are also on the inside of the parallel lines that are alternate interior angles. Nate, what do you think? Okay, good. B right here and G right here. So we also know that B is equal to G by alternate interior angles. Okay, now we have what's called alternate exterior angles. So again, if we're looking at the parallel lines, we just did the inside of the parallel lines. Now I'm going to do the outside for exterior. Can anyone tell me angles that are on the exterior that we know are equal? Kira? Okay, good. E and D. So E is going to be equal to D by alternate exterior angles, A, E, A. Okay, and then there's one more set, of course. And Stephen, what's the other pair of angles? Good. So A is equal to H by, oops, A, E, A. All right, and there's one more thing we're going to learn, and they're called corresponding angles. So corresponding angles means that they are in the same spot, all right? The same spot. So what does that mean? Let me erase all my markings here. So you kind of look at these four as a set of angles, and these four as a set of angles. And so A is in the same spot as C. So those are corresponding angles. We know they're equal. A and C are going to be equal because they're in the same spot. So corresponding angles, we already used CA, so I don't really know what else we should use. Corresponding angles. How's that? Okay. So A and C are in the same spot. Who can give me another one that's in the same spot? Let me compare those two. Ethan? G and E. I agree with you. Those are corresponding. G is equal to E by corresponding angles. Okay? All right. Who can give me another set? Let's see. We already did C and A, right? And E and D. Okay. Ethan? Good. B is equal to D. Whoa. And if we do B and D, boom, now we have F and H in the same spot. All right, so that was a whole bunch of information about the angles. What do we know about the lengths? So we've got parallel lines and we've got a transversal. So right here I have three parallel lines. How do I know they're parallel? They have this little arrow thing right here, so that means all three of these are parallel, okay? And then I have a transversal and a transversal cutting through those parallel lines. So this is important. We can actually write proportions. So A over B, that distance, A over B, is going to be proportional to D over C. So we can actually go down this to this equals this to this. Or we can go across and write a proportion. So I can say that A over D is going to be proportional to B over C. So either one of these works. So you can write your fractions this over this or this over this equal. So let's try a real problem. So my lines are not proportional, in case you can't tell, or they don't look right, because like if that's 2, then 5 would definitely be more than that, but that's all right. So what we're going to do, I guess what I could do is move this line a little bit, right? Oh, no, can't. Oh, maybe I can. Oh, I can. Yeah, that would make a little more sense. If that distance was 2 and this distance was 5, right, we would need a little more space there. All right, that's probably better. So, again, you can write your fractions, this over this equals this over this, and you can solve. Or you can write it as this over this, which kind of makes sense because it looks like a fraction right there, is equal to this over this. So 8/3 over x. Okay, they have to be proportional since they're being cut by parallel lines. And what do we do after we write a proportion here? Yeah, cross multiply, thank you. So 2x is equal to 5 times 8/3. So how do I deal with the 5 times 8/3? Probably want to put 5 over 1 so it looks like a fraction, right? And we can multiply these top to top, bottom to bottom. And when you divide by 2, it is the same as multiplying by a half, which might be easier because we have a fraction on the right-hand side. So if this is 2 over 1, we multiply by the reciprocal here, 1/2, and we multiply by 1/2 on the other side. And so x is equal to, cross cancel here, 2 goes into 40. So I get 20/3. Okay, if there was a distance on here, say they gave you centimeters, inches, since we're talking about length, you would put units, okay? All right, so back to some angles. Since we just learned a bunch about angles, we wrote down all those properties, right? Now we're going to use that information to solve for some angles if we have variables thrown in there. So we have 2 parallel lines, and then we've got a transversal, and I want to find some information here. So where could we start? There's a couple places we could start here. Nate. Perfect. So we can actually say that these are equal angles right here. How do we know that 2b is equal to 130? Ethan? Very good. Corresponding angles. We know for sure those have to be equal. So divide by 2, and what is b equal to? Good, 65. And for our answer, we'll put degrees when we're solving for angles. Again, is this entire angle 65? No, this entire angle is 130. It kind of helps to put that on there because it's 2 times 65. Okay, so now we need C and A. There's a few ways we could find C and A. Leo, what do you think? C is not 130 because that would mean it was equal to this angle right here. Does it look like this is equal to this guy? No? Okay, what do you think? 2 supplementary angles, okay? So we could say A plus 130, because there's a straight line there, has to equal 180, so those would be supplementary angles. Subtract 130, and A is equal to 50 degrees. If A is 50 degrees, what is C? Yeah, we just know C is 50 degrees. How do I know? It is corresponding with the other one. I lost my pen. Come back. Oh, and we're back. There we go. So So even if you just put an answer down, right, like that, we have to put a reason how we know that, so corresponding angles. We could have done another supplementary angle with this one here, but then we would have had to write the equation for 180, which is more work, so I might as well use corresponding angles. Okay, a little triangle review. What angle do we have to find first, x or y? Yeah, we have to start with x, okay? How are we going to find x? Someone new. Lindsay, what do you think? How are we going to find x?
Supplementary.
Good. Okay, we know these add to 180. Okay, so x is equal to what? Okay. So, y, yeah, Nate? Cool, thank you. All right, now we can find y. How do we know? How are we going to find y? What are we going to use? Leo? Good. So we can set all three of those angles equal to 180. And our reasoning for this, I don't remember if we did this, but we use TS, and that stands for triangle sum. Okay? Triangle sum. So we have 75 and subtract 75, and y is equal to 105. Okay, isosceles triangles, it's really important to notice when triangles are isosceles. So if you have these little marks here, okay, if you have an isosceles triangle, two sides are the same, that also means you have to have two angles that are the same, those two base angles. Okay, they're always equal in any isosceles triangle. So it says M angle A. What this is saying is the measure of angle A is 35 degrees. So I can go ahead and write that on my picture. Find B and C, okay? Easily we can find C. What is C? Right, it's 35. We just said the base angles are equal, but we need a reason for that, okay? So this is new for you. So C is 35 degrees. We are going to use IT, and you might want to write that in your notes just for now, but you can just use IT in the future, isosceles triangle. If you can't remember the shortcuts, you can write isosceles triangle, okay? It's totally fine. All right, now it should be easy to find B. We just did triangle sum in the last problem, so we have 35 plus angle B has to be equal to 180. Again, we need a reason on there, triangle sum. 70, subtract 70 from both sides, and B is equal to 110.